Homework 4.3, Properties of Logarithms, Video 7. Homework due Friday, May 29th at 11:59 p.m. This final video in this series is associated with homework questions 20 through 21. I mentioned that there are 4 properties we are going to review in this series of videos, or rather learn in this series of videos. The first 3 were the product rule, quotient rule, and power rule. The third one is the power rule. The fourth one is called the change of base property. And I debated whether or not to just put it up there and say, here it is, let's use it. But for the benefit of those of you going into higher level mathematics, I want to show you where the change of base property comes from by attempting to evaluate a logarithm that we can't just find the answer without a calculator, and we seem to be stuck because our calculator only has 2 log buttons, log and ln. Log being log base 10, ln being log base e, this being neither. And then after solving what this equals to, we're going to turn it into a property that we can use in general. So how do you evaluate something that you can't just say, I know what the answer is? There's a trick to trying to figure out what something equals. The trick is, call it a variable. So for example, let's just call the answer to this x. Then, rewrite the equation somehow and see if you can solve it. Now technically this is already solved. It says x equals, that's the goal when you solve. But can I rewrite this in a different form and then attempt to solve it and get a different looking answer for the x? Sure. Isn't this equation written in logarithmic form? And in the previous series of videos, didn't we learn how to rewrite between logarithmic and exponential form? Let's rewrite this in exponential form. That says form, believe it or not. That's better. And remember, to rewrite a logarithmic equation in exponential form, you simply have to write what the answer to the log does. The answer to a log is a power that turns the base into the argument. In fact, we saw this logarithm earlier, I think it was in the first video, where we ran across log base 3 of 5, and prior to that we had log base 3 of 9, which we could answer. It was 2, but we couldn't answer this one without a calculator. That's about to change. Well, we'll be able to answer it, but with a calculator. Okay, so if I rewrite it in exponential form, that's okay. It loses the logarithm, but it takes me further away from my goal, which is to solve for x. The x is currently in the exponent, and I can't solve for it while it's up there. So how can I drag the x out of the exponent? Put it in logarithmic form. That'll just take us back here, so let's not do that. What could we possibly do to take this x and pull it down in front? Oh, wait a second, that sounds familiar. Where else have we taken an exponent and put it in the front? Here. If we have a log of an argument with an exponent, or power, we can pull the power down and put it in front. Can we do that here? Well, not yet, because the power rule says something you can do if you have the log of a power, and I don't have the log of a power, I just have a power. But wait a minute. We all know that whatever you do to one side of an equation, you can do to the other. So if I want a log in front of this, can't I just log both sides? Now when you pull a logarithm out of nowhere, you have to choose a base. Let's just choose base 10 so that I can just write log of 3 to the x power equals log of 5. By deciding to log both sides, I've just set up the left side of the power rule, and so now I can use the power rule, which says take the power off the argument and put it in front of the log. So if you use the power rule, then we can take this power x and multiply it in front of log of 3. And now that does 2 things. Number 1, it gets the x back down on the ground. And number 2, it puts it in a position where I can solve for it. Because the only reason the x isn't by itself is because it's multiplied by something. Well, I know how to get rid of stuff that's multiplied. Divide. So let's divide both sides by the thing preventing the x from being by itself. Log of 3. The log of 3 cancels, and we get x equals a fraction with log of 5 over log of 3. What's that equal? I don't know yet. But 2 comments. Number 1, don't cancel the logs. What's the rule for canceling a fraction? You can only cancel parts of multiplication problems. Does this say log times 5? No, it's log of 5 because it's a function, not a multiplication problem. So don't cancel the logs. But more importantly, don't we have a log button on our calculator? Yes, this can be worked in a calculator. If I can spell. And when I say this, I don't just mean the top, I mean the whole thing. So if you have a calculator, and you should by now, get it out and work it out. I'll do it in 2 calculators and display in one line. So it's about to go a little bit out of focus in just a second. Here we go. Don't need pi. So, come on, focus. Focus. If we want to do log of 5 divided by log of 3 in this calculator, we just have to press log. Now notice it opened a parentheses for me. Of 5. Now we do have to close this parentheses because that closes off that logarithm's argument. If we don't, then we're putting the division sign inside the logarithm. And it's important to point out that that division is not inside the log, it's underneath it. So back to this one, we need to close off that logarithm's argument and then divide by log of 3. I think I could leave that parentheses open, but that just bugs me. And if I press equals, it will give me a big old irrational number. Well, it's not that big. 1.464973521. So if we round this to 3 decimal places, the first 3 are 464, the next digit is 9, so it's going to round the 464 up to 465. So 1.465. If you have a display calculator, you pretty much type in the problem like you see it. Where's my finger? There it is. But if you have a one-line calculator, like this one, remember, if you have a one-line calculator that only displays either the last number you entered or the last answer it calculated, log will calculate on the number that is entered. So if I want to do log of 5, I have to first press the 5 and then press log. There is log of 5. So to do log of 5 divided by log of 3, you would press 5 log divided by 3 log, and then press equals to finish the division, and we got the same answer as before. 1.465 if you round it to 3 decimal places. Come on, focus, there we go. All right, so using a calculator, this ends up being 465. Approximately 1.465. And in the homework, it will ask you for 2 answers. It will ask you for the exact answer. That's the answer that didn't go into the calculator and did not get rounded. And it will ask you for a decimal approximation. I think 3 decimal places. I can check real quick. Actually, this one says 4, but let's not worry about that. I'm assuming if you know how to round to 3 decimal places, then you know how to round to 4. Well, that's neat and all, but am I going to have to do all this every single time? Both times that I'm asked to evaluate a logarithm that's not one of the buttons on my calculator? No, because this is how math gets discovered. You solve one specific problem. This stuff happened. Some of it makes sense, some of it is naturally instinctive, some of it is not, but it happened, and we got x equals this, which went to the calculator. And ask yourself, what rule can we make from this? Well, this is equal to this, but what was specific to this problem? The 5 was specific to this problem. So if we changed the 5 to anything else, the flow would still be good. So this 5 can become any variable we want. What else was specific to this problem? The 3, which showed up here. So it stands to reason if this 3 were any other number, it would have showed up here, so we can replace it with a variable. And there's one other value that was specific in this problem. It's a little subtle and stealthy. But when we took the log of both sides, we used log base 10, didn't we? And the choice of the base was for convenience, but it wasn't absolutely necessary to get us here. So for example, if for whatever reason I decided I wanted to do log base 7, everything else would have been the same, except I would have had 7s here. So there are actually 3 specific values used in this specific problem. The original argument, the original base of the log, and the new base of the log that we brought in to execute the power rule. So how can we make this generic? Well, we start by writing this problem generically. Log, let's see, what's a good generic letter for base? How about B? And what's a good generic base for the argument? How about A? And then it ended up equaling this. So let's see if we can preserve what this structure is. We had one log on top of another. But the argument of the log in the numerator was the original argument of the logarithm. So the original argument of the logarithm was A. The argument of the log in the denominator was the original base. Since the original base was B, that means that this log's argument is also B. And out of nowhere, we brought in a new log with a base of our choice. I can't use A, I can't use B, let's use C. And voila, just like that, we have what's called the change of base property, which does exactly as its name implies. The base changed from B to any base I want. Now, guess which base you should choose? Well, in order to make it calculator workable, you should choose base 10 or base E. In other words, you could use natural log here instead of log. In the homework, it says use common logarithms or natural logarithms. So you could use log or you could use ln. Let's take a look at another one that's not inventing the wheel, but rather capitalizing on this invention. And these problems are easy to make. You just need a couple of numbers as long as they're positive. For example, let's say I wanted to know log base 7 of 100, which is asking the question what power turns 7 into 100. According to the change of base property, I can set up a ratio of logarithms where the original log's argument is the argument in the numerator, and the original log's base is the argument of the log in the denominator. And I can use any log I want here. Log, meaning base 10, or I could use ln, meaning base E, and frankly, I could use any base I want. I could use log base pi. I wouldn't, but the point that I'm making is the change of base property allows you to change it to any permissible base, meaning positive but not 1. So all 3 of those are correct, but only 2 of them can go on the calculator, the top 2. So I invite you to get out your calculator and put either this one or that one in. In fact, I invite you to do both because they should give the same answer. In fact, I'll do one of them one way. I'll use one calculator to do one way and the other calculator to do the other way. All right, let's do the ones using log in this one. All right, so it was log of 100 divided by log of 7. Log, how about on? That would help. Log of 100, close parentheses. Wait a second, I know what that log equals. You should too. What power turns 10 into 100? 2. But I'm using a calculator, so I'm not going to worry about it. Divided by log of 7. This video went longer than I thought. That's what I get for inventing the wheel. And we get 2.366589325. But had we used ln, which I'll do in the other calculator, and remember, in a one-line calculator, before you execute a logarithm, you have to type its argument. So to do natural log of 100, I have to type 100 and then press ln, and then divided by 7 ln, and then equals to finish it. And if I'm not mistaken, we got the same answers. So to three decimal places, that 5 would round that up to 2.367. To 4 decimal places, that 8 would round it up to 2.3666. Let's round it to 3, so I don't have to write 666. So to 3 decimal places, it would round up to 2.367. All right, so change of base property answers the question, how do I put any logarithm in my calculator? One last comment. Some of you, depending upon how new your calculator is, may be able to type something like this, and it'll allow you to type any base that you want. If you have it, good for you. If you don't have it, that's okay. Change of base property puts us all on a level playing field. And that's the end of this homework. You got any questions, let me know. Dagnabbit, that's out of focus. So let me say that one more time. Some of you may have a calculator that's sophisticated enough that will allow you to type this and type in any base that you want in any argument. If you have it, great. If you don't, that's okay, because the change of base property puts all calculators on a level playing field, provided they have log buttons to begin with.